Section 4.1, we're going to do example 2, and this time we're going to classify triangles using their sides only. In example 1, we did their angles, but now we're going to do their sides. And there's 3 choices. We have an equilateral triangle. When all 3 sides are equal, it's an equilateral. So here we're going to put a little equal sign under that, and lateral we're going to just put the word sides. Okay, equilateral is equal sides. Equiangular is equal angles. Okay, isosceles, when I took geometry a long time ago, many moons ago, my teacher was trying to be funny to help us remember this, because the key here is 2 sides are congruent, and that third side is not congruent with the 2 that are. If all 3 are congruent, it's equilateral, but if only 2 of the sides are equal, it's isosceles. So he made up kind of this isosceles, like you're across the street, okay? And here's you, and here's Celes, another person, I guess that's somebody else's name, and you saw them across the street. Well, that's what these represent. You're looking across the street and you see them there, and they're equal, isosceles. And he was being really silly, and it made no sense, but you can tell I still remember it all these years later. That's what the most hilarious part of it is. All right, in scaling, none of the sides are congruent. So all 3 sides are different in length. So let's take a look at example 2, and let's check out this remember, because sometimes they give you some really good ideas here. When you look at a figure, you cannot assume segments are congruent based on their appearance. They must be marked as congruent. Don't assume that things are the same length unless they are marked that way. Okay, so classifying triangles. So this time they want us to look at A, B, C. So here's A, B, and C. Okay? So we can ignore, let me kind of mark out this part. We're going to ignore that part and just focus on ABC. Okay? Now they have it marked. It might look to you like, hey, they marked with tick marks. 2 of the sides are congruent. And they're showing that congruent, that AB, segment AB, is equal or congruent to segment AC. Well, we know that congruent sides mean that their measures equal each other. So that means that AB and AC equal each other as far as how long they are. So if AB is 15, then AC is also 15. And then they showed us that BC is 15. So when all 3 sides are equal, we're going to classify that as being an equilateral triangle. That's how you're going to call that, okay? Let me get my eraser out. Let me clear this up so we can get to the second one. All right, triangle ABD. All right, so A, B, and D. So we're doing the whole thing, the big one. All right, so we know that this side over here is 15, and we know this side over here is 18. This whole thing from B all the way down to D, you're going to have to do the segment addition postulate and add these 2 together. 15 plus 5 is 20, okay? Now, when you have a side that's 15, another side that's 18, and your third side that's 20, they're all different. So how would you categorize or classify this triangle? Yep, it's a scalene. Good job. Very proud of you guys. All right, so the check it out is for you. You're going to do ACD, and you're going to classify that one. So I'm going to put a +1. Do your best with that. Hopefully it's review. If not, bring your questions to class and let's talk about it.